Hello students, and congratulations to making it to the fourth quarter. How incredible. You've learned so much already in physical science. We have talked so far about physics and all the different subjects there like thermodynamics and optics and mechanics. And we've had a lot of labs and they've been really cool, from the egg drop lab, which I'm sure you remember well, to calculating kinetic energy, to observing heat transfer and force through different cars. But chemistry is a totally different subject, and that's our subject as of fourth quarter. We're going to be studying all fourth quarter about chemistry, and chemistry has a little bit of danger that physical science didn't have. And I have to warn you about this danger before we can do any labs in chemistry, because I don't want any of you to get hurt. And since there is 32 of you in this class, I have to be really careful to make sure that all of us are doing the same thing, because I can't keep my eyes on all of you. So I'm expecting even better behavior than you had in the physics labs, and you guys did awesome in those, and we had a great time. Now, if you would turn to Lab 24 in your lab books, that is page 173, we're going to be looking at the purpose of lab safety. I'm sure you already know, but the purpose of lab safety, as outlined, number one, is to become familiar with the lab safety rules and the general procedures of a chemistry laboratory. And number two, to become familiar with certain standard chemical laboratory practices. These practices are practiced in labs all across America. And if you ever become a chemist or a biologist or work in any sort of other field that might involve chemicals, you're expected to know these rules that I'm going to teach you in this classroom. So it's very important. And some of you might be thinking, well, how am I ever going to use chemistry? I just want to become a car mechanic. Chemistry is everywhere. If you want to become a car mechanic, don't you think that there were chemical engineers involved in making all the different components and the oil in cars? It's incredible. The Bible says in Psalm 111 verse 2, "Great are the works of the Lord, studied by all who delight in them." Now, as we take a look at these safety rules, I'm going to be interjecting this video that I found on YouTube, which does a great job at explaining. I think you'll find it comical because it uses some puppets. But this lab safety video does a great job at explaining lab safety. I'm going to be interjecting, asking some questions, checking for understanding, and make sure that everybody understands not only what we do, but why we do it. Well, let me get off out of the picture and let you watch this lab safety video.
Smell indirectly by wafting. Don't smell chemicals directly.
Oh boy. Can anybody think of a substance that you wouldn't want to smell directly? That's right. An acid. An acid would be a great example of a chemical you wouldn't want to smell directly. Hydrochloric acid is so strong that it will literally burn the nose hairs in your nose, and it will burn all the way down your trachea and even into your lungs and cause some really bad damage. And most of the time we don't know what's sitting in a particular vial or test tube, so we've got to be very, very careful. Let's continue on with our lab rules.
Don't eat or drink in the laboratory. Don't wear loose items, including hair and clothes.
Students, as funny as this is to watch the girl's hair catch on fire, the reason it's in the video is because it has happened. Make sure before you do any chemistry lab, you tie back all the loose hair that you may have, especially you guys. I'm just kidding, you should probably have short hair to follow the rules at our school, but additionally, roll up loose clothing. Now I have short sleeves on. This is Florida. If you're wearing a long sleeve jacket, you're crazy, okay? But if you do have a long sleeve jacket on, please roll it up. I don't want any jackets dipping into any acid or anything that might get on your skin. We got to treat that very seriously.
Here's safety goggles. Don't take off safety goggles. Read instructions before mixing chemicals. Don't randomly mix chemicals.
Unless you are a chemistry expert, you probably don't know what two chemicals, when they're mixed together, make. Maybe they make nothing, but maybe they make something that's really, really powerful. For instance, an example of really a very unique chemical reaction is one which includes sodium. Sodium on the periodic table is called Na, and involves hydroxide. Hydroxide is one of the strongest bases out there. Sodium hydroxide, a very, very strong base. You get this on you, it is very powerful. It's going to hurt you. And hydrochloric acid, HCl. You've probably heard of hydrochloric acid before. Hydrochloric acid, one of the most powerful acids you can ever encounter. And hydrochloric acid and NaOH, when they combine, the hydrogen and hydroxide combine to make water, and the sodium and chlorine combine to make salt. They make salt water. Incredible. Two of the most powerful things in the known universe combining to make salt water. If you did this experiment correctly, you could literally drink the result. I wouldn't recommend it. Again, our previous lab rules were do not eat or drink in the lab, and that especially includes chemicals. But theoretically, just because you have two chemicals doesn't mean it's necessarily making something bad when they react, but it most certainly could. Imagine if the flip side happened and hydrochloric acid was created. This acid is very volatile, it evaporates very quickly, could get into the air, and could really damage you. Some of you know about some household cleaning products, for instance, ammonia and bleach. Does anyone know what happens when you mix ammonia and bleach together? Yes. You are correct. It creates a noxious gas. In fact, the gas is so powerful that is created through the mixing of these household chemicals that you literally have to call the fire department to clean out your house when those things are mixed. How incredible that two different chemicals can mix and make something so dangerous. In fact, two different chemicals that you can buy at Walmart for 99 cents each. It can potentially be very dangerous. Please read the lab instructions every time and follow those lab instructions to the letter. Let's continue on with never pour chemicals back into the original container.
Never pour chemicals back into the original container.
No. Don't pour it back.
Let the instructor clean up broken glass. Never pick up broken glass with your bare hands. No horseplay in the lab. Wash eyes for 20 minutes immediately when exposed to chemicals.
What a amazing rule that is. No horseplay in the lab. You have to be incredibly careful. You guys are 14, 15 years old. You're in 9th grade. You might think you're invincible. But you have to be very, very careful. Sometimes you're horseplaying in the lab. Things break. People get hurt. And I don't want that happening on my watch. And if you do get hurt, you have to tell me. Okay, I'm not going to get angry at you. I'm going to try and help you. Okay, if you're cut, I got to make sure that wound is treated properly. If you get something in your eye, we have to go back to the back and look at the chemical eye wash station and make sure your eyes are going to be okay, especially if you're wearing contact lenses or if your goggles were off, which really they shouldn't be off when you're dealing with dangerous chemicals. In fact, my alma mater, Bob Jones University, you couldn't even wear contacts into the labs. You had to put on your glasses because if a chemical got on your contacts, sometimes it would make them react with the eyeball, and that could be a very bad thing. And always be safe in lab is their last point. And of course, that's the one that I'm most concerned about, is that we are very, very safe and that we have a lot of fun. Now, I'm going to remind you of two things that the Bible says in the book of Proverbs. The first one is in Proverbs 22:3. It says, "The prudent sees danger and hides himself, but the simple go on and suffer for it." The prudent person, prudent student in lab is going to look and think about the potential danger that he sees and hide himself from it. He's not going to do it. He's going to prevent those mistakes. But the simple are going to go on, and those are the people that are going to get hurt. Don't be the simple man in Proverbs. And the second verse in Proverbs 14:15, the simple believes everything, but the prudent gives thought to his steps. Make sure you're the thoughtful person in lab. Today's lab has very clearly outlined procedures that we are going to follow that I'm going to demonstrate for you. And you need to make sure that those procedures are things which you are following, and you are following very closely. Don't go off on your own and try and make up your own procedures and your own rules. It's a recipe for you getting hurt. Now, let's make sure that we put our masks on, and I'm going to put my mask on because I'm going to be within 6 feet of you, and we're going to take a walk around the lab and show you some different lab equipment that you are going to encounter and where those things are and how they can help you. Hello students, we come to our first piece of lab equipment. This here is the Air Science Ductless air filter. And what it does is it soaks up any harmful gases that might be created in a chemical reaction. All you do is press this green button here to turn it on, and this lid comes down to trap anything inside this ductless air filter, and you can watch the reaction take place, and it's not going to be something that could potentially harm you. The air is trapped inside and it's filtered so that we're not breathing in any gases that could potentially hurt us in this classroom. We also will make our way over here. Past the fridge, you see this little station over here where we have some Lysol to spray stuff down. That's pretty useful with COVID. And we also have this fire extinguisher. Now, let me be very clear. I think the fire extinguishers are really cool. When I was a kid, I wanted to be a fireman, but please do not use the fire extinguisher unless I am unconscious and there is a fire. If there is a fire, please let me know, and please let me use the fire extinguisher. Of course, we've never used that in the classroom, and that is a very fortunate thing. Here is the eye saline solution, the stuff that you will have to wash your eye out with if you do get an eye injury in lab. That's for your own safety and protection. And I'm gonna help you wash your eye out. And we do have to wash your eye out for 20 minutes. I've never used that in lab because we've been so good about keeping our safety goggles on. Next, you have what you see over here as the chemical shower. The chemical shower is something which pours water onto you so you can wash off the chemicals on your body. Again, I've never used it. This is my 5th year teaching here, and I've never had an accident bad enough that a student couldn't wash off their hand or their arm in the sink that they'd have to use the chemical shower. But if you spilled a large amount of a toxic substance on you, we would have to, for your safety, use that chemical shower and make sure that that chemical got off of you. Now, here is where the lab aprons are kept. These are washed regularly, and each time you use a lab apron, please put it in the disposable lab apron bin over in the bottom right corner of the classroom. We also have the place where you keep the lab goggles. These goggles are very important. You do have to wear goggles even if you have glasses like me. And here is where we keep a reminder of our lab rules. These lab rules go into depth. You have a copy of this lab rule in your syllabus. And as a general reminder, and I do this every year, we will have a quiz over the lab rules tomorrow. It will be a 10-question true-false quiz just to see if you understand the content, and you will have to pass that quiz in order to keep participating in labs for the rest of the year in chemistry. You can take the quiz any number of times, but I will take your first score for the grade book. Now, let's begin, and you're gonna watch me properly suit up for lab and make sure that I am properly dressed so that I do not get hurt. And then you're going to do that yourselves and model the same process that I do. Okay, the first thing that I'm going to do is I'm going to put on my lab apron. And the lab aprons are in great condition. These were bought just about a year ago. And you're going to slip the first part over your neck and tie the second part behind your back. Now, I have been wearing lab aprons for a long time now, ever since my freshman biology class about 10 years ago. So I have tied many lab aprons behind my back with a nice double knot that I can very easily undo. Unless you are skilled like that and have the natural ability, you probably need some help. Please ask a neighbor to tie your lab apron as well. I also have some lab safety goggles. These are adjustable and fortunately fit right over my glasses. And so these goggles are pretty secure, and they're very nice because even with the masks on, they are very breathable, and you don't have any fogging up which occurs. And lastly, if applicable, I have a great number of gloves which you can wear, and these gloves are found on top of the table in the rightmost corner of the lab. And these gloves, of course, are to help protect your hands. Now, of course, if you take a look at me right now, you'll see that pretty much my only things that are exposed on my body are my arms and certain parts of my neck. We have done a great job at protecting all of our vital things that could potentially be damaged in lab. Now, certain labs you're going to need all of these equipments. Certain labs you're not going to need hardly any of this equipment. Fortunately, today we are simply learning how to light a Bunsen burner and bend glass tubing. For this particular lab, because there is no chemicals whatsoever, there is no need for either of these gloves, and there is no need for our lab apron. However, there is a need to wear the lab safety goggles because fire, of course, can potentially hurt your eyes if you have a gas leak somewhere. You have a little tiny explosion that happens in the lab. You could singe an eyelash or two, and you got to be very careful, especially you guys, since you're novice at lighting the Bunsen burner. Sometimes gas will leak out into the surrounding area before you get it quite right, and you could potentially hurt yourself. So while I go put these things back, I want you to grab your lab safety goggles and put them on. And why don't you practice putting on an apron as well, and then just take it off and put it back where you found it. You did a great job with making sure that everyone has goggles on and everybody even got the apron on. Some of you were able to tie it correctly behind your back. What an incredible skill to have. Good job. So, we're going to be learning about how to light the Bunsen burner. Here I have a striker, and you're able to see how why it is called a striker, I should say, and it's because you strike it and it creates a spark. And the spark is very important because it is able to light a Bunsen burner. This device here is called the Bunsen burner. When plugged in, it will supply from the propane tanks that the school has a steady supply of gas through which to sustain a fire. Now, if you see here on the middle of the Bunsen burner, there's a little window, as many people call it. It's technically called the air supply valve. When the air supply valve is closed, the Bunsen burner is going to have a red flame. When it is open, it's going to have a blue flame. Does anyone know which one of these is hotter? Yes, sir. You are correct. It is the blue flame. You remember that from Earth and Space Science, where we learned about suns. The blue ones are typically the hotter suns, and the red suns are the cooler ones, because blue fire is warmer. This fire can get up to, at its hottest, 500 to 600 degrees Fahrenheit. That is very, very warm. So you have to be very careful. Now, I'm going to plug in my Bunsen burner into this gas supply, and I'm going to make sure that it is securely fastened. If you don't securely fasten it, you could have some gas leak out, and that would not be good. I'm also going to take proper precautions. What do I mean? Okay? I'm supposed to hold the striker directly over the Bunsen burner and strike in order to light it. But what if I hold my hand too close? I could potentially injure myself by harming my hand. Or what if I have the Bunsen burner with the flame underneath the cabinets? Well, if this flame indeed is 600 degrees, I could potentially light the cabinet on fire. That would not be good. The school would be rather upset at me. Now, I'm going to move this a safe distance away. When you turn the gas on, you probably won't be able to hear it from back there. But when you turn the gas on, it's going to have a small sissing noise that you're going to be able to hear. That's going to tell you that the gas is going. And you're going to want to start with the window closed on this Bunsen burner. If the window is open, there's going to be a lot of oxygen, and it's going to be really hard to start this Bunsen burner. Now, I'm going to demonstrate it, and I've lit Bunsen burners really hundreds, if not thousands of times. And so this is going to look very easy for me, although it's probably going to be somewhat difficult for you. So here I go. I turn the gas on. I can hear the sissing noise. Put the striker over the Bunsen burner. I strike once and the fire is lit. Now, if I want that warmer flame, I'm going to make sure that I am keeping away from this flame. Open the window, and there you see, you can barely see it blue in color. You might be able to hear it a little bit better than you see it. That is a very, very warm flame. And when I want to stop this flame from occurring, I simply will disconnect the gas from going into that gas line by pulling back the gas valve and cutting off the gas. And as you can see, this Bunsen burner has ceased to work. Be very careful to make sure that you keep away from the fire. You don't want it hurting anyone, whether it be you or your lab partners. And you just want to take general safety precautions when you're doing so. What we're going to do now is I would like every single person in here to practice lighting the Bunsen burner as specified. I have 6 Bunsen burners and 6 gas hookup lines that you can use, and you're already put into your groups. And so this should not be very difficult for you. We have 6 groups of 5 or 6 people, and we are going to practice lighting this Bunsen burner. I want every single person to be able to do that. I would recommend giving the striker a few strikes before you try to do so, just to make sure that you build confidence in your ability to light the Bunsen burner. You guys did an incredible job at lighting the Bunsen burner. This is one of the largest classes I have ever taught, and all of you were successful in lighting the Bunsen burner. I was kind of pleasantly surprised about that. Some of you took a little bit long in getting it started, and you saw what I meant by having the gas leak out a little bit and the fire kind of poof at first and cause a little bit of a bigger flame. That should allow you to be mindful of the fact of what propane gas indeed can do, and how we need to be mindful of that and to light our fire quickly to avoid any potential injury. That was great. Here I have a piece of glass shaped in kind of the letter J, and this is a glass that I have previously bent for a different class. I try not to waste glass, so I'm going to reuse this one. And this is a thicker piece of glass. Most pieces of glass that you're going to be using are thinner than this. Can anyone think of a reason why we might potentially bend a piece of glass for use in this science lab? Yes. That's a great reason. The reason that she gave was so that we can make the glass into the shape that we want it. And since glass is movable, maybe we want to move water from one location to the next, but we need a specific shape of glass to do so. I can actually bend this glass into the shape that I want it to be in. That is a great answer. Now, let's consider the fact that this glass is a little bit thicker than some of the others, so it might take a little bit longer to burn. I don't want to pull or push too hard on this glass to try and get it to prematurely bend, and the reason is because it could possibly break. Please remember that it is glass, and glass does break, and the purpose of this lab is not to break the glass tubing. If you do break the glass tubing, just make sure that you allow me to clean up the glass. You should feel when it is ready to bend, because it will start to be flexible in your hand without much effort. As soon as it becomes flexible, you'll notice step 3 in your lab manual says to remove it from the fire, and step 4 is to slowly bend to the desired shape. Now, as you can see here, I have my J-shaped glass. I'm actually going to try to make this into a square. Now, I'm not sure how a square would be useful in lab, but that is my goal. I'm of course going to keep my hands off of the hot glass afterwards, and I'm going to very carefully put it in a place where it would not be touched by another student, and that is because I don't want someone to get hurt. Remember, as is stated on rule number 16 of our lab safety sheet, be careful with hot glassware. It looks cold. See, glass, unlike what a movie might portray, looks the exact same when it is both hot and cold, although it has many different properties when glass is warmed. For instance, it has what we learned in physics as plasticity. It is able to bend. Now, let's show you the proper lab technique to bend glass, and then I'll give a glass to each group, and you can fashion it in whatever shape you desire. Please make sure that before you pass it on to the next person, that it is cool. The glass will cool somewhat rapidly, okay, but you don't want to stick your hand on it to figure out whether or not it is hot. You can actually feel the heat coming off of the glass. So don't touch, but hover, and you should be able to feel whether or not that glass is still hot. Let's close the valve of the Bunsen burner. I'm going to turn the gas on, and with one quick stroke, I'm going to light the Bunsen burner. Some of you guys are able to light it on the first try. You have an incredible skill. Very rarely do people actually light the Bunsen burner on the first try. Others of you were clicking this striker over and over again to get it to light. It took you a couple of minutes. Now, really quickly, I'm going to change the flame to be blue. And as you've learned, and as step number 2 says in your lab manuals, that you're supposed to hold the glass over the tip of the teal flame. I'm going to put the glass on the tip of the teal flame, and I'm going to move it back and forth. And the reason I'm going to move it back and forth is because if I put it directly underneath this blue flame, it's going to be something that heats up a little bit too quickly. And every once in a while, I'm gonna bend it, trying to determine whether or not, oh, there you go. And I made a perfect square. Trying to determine whether or not the glass is able to be bent. And as I was bending it, I noticed right away, wow, this glass is becoming increasingly characterized by its plasticity. I pulled it out of the Bunsen burner and I was able to bend it. And as you can see, I made my square that I wanted. And it was very easy to do, but I did need some quick reflexes because as soon as it starts to bend, it's going to take the shape that you want it to take, and that shape takes place very quickly. And so I had to think quickly and design my square. Now, I'm going to hold my hand over this portion of the glass, and I can tell that it is pretty hot. I can also, as I'm holding something pretty close to the spot at which the glass was being burned, I can feel it's a little bit warmer than normal. So what I'm going to do is I'm going to place it right over here where it can hang and be able to cool off over by the other sink. And I'm going to shut the gas line off, and thus my Bunsen burner turns off, and I'm going to let my glass cool, but stay in the area to make sure that everybody knows that that glass is off limits until a couple minutes from now where it is no longer hot. So everybody get back into your groups, design and talk with your partners about a way to bend the glass, and please make sure you stay safe and exhibit proper lab procedures following the rules of Lab 24 as you bend the glass into the desired shape that your group chooses. All right, let's go at it. Congratulations on an incredible day yesterday. You successfully lit the Bunsen burner and successfully were able to modify the shape of your glass tubing. We had one group, Jacob's group, you created the snake. That looked really, really interesting. And Aya's group, you tried to create a Pikachu, was it? Well, I'm sorry, Aya, but I don't think that the developers of Pokemon want you designing their Pikachu. You probably have to work more on your glass tubing art before you do so. But great job, you all demonstrated proper lab technique. Amazing job. Please put all of your notes away. We are going to have our quiz. The quiz should be on your desk right now. I will read it aloud to you, and you can read it silently by yourself. Every question is a true or false question. When you get done with your quiz, please flip it over to the back, and I will be collecting those quizzes at the end when everyone is done taking them. Question number 1. Hot and cold glassware look the same. You have to be careful when handling them. True or false? Question number 2. You may clean up broken glass only if you are wearing gloves. True or false? Question number 3. Safety goggles or safety glasses are not needed unless you have some pre-existing eye issues. True or false? Question number 4. Glassware does not need to be washed before use because you could potentially contaminate it with soap. True or false? Question number 5. Chemicals, also known as reagents, should never be returned to their stock bottles. True or false? Question number 6. If cutting something in the lab, cuts should be made away from your body rather than towards your body. True or false? Question number 7. The science lab is equipped with both a fire extinguisher and a fire blanket. True or false? Question number 8. The Bunsen burner must be firmly secured to the gas line. True or false? Question number 9. Minor accidents do not have to be reported to your instructor. True or false? And lastly, question number 10. True or false? Always follow the lab procedure given to you before lab time. When you are finished with the quiz, you may flip it over and we will go over this quiz in just a minute so you can have the correct answers. Okay, let's review this quiz. Question number 1. Hot and cold glassware look the same. You must be careful. True. Question number 2. You may clean up broken glass only if you're wearing gloves. False. Can anyone tell me why that statement is false? Yes, Bella. You are correct. You should never be cleaning up broken glassware. I should be the only one handling broken glassware. Number 3, safety goggles or safety glasses are not needed unless you have some pre-existing eye issues. Victoria. That is false, and the reason being is because everyone needs safety goggles to prevent eye issues from occurring. You are correct. Number 4, glassware should not be washed before use. You could contaminate it with soap. That is false. Tell me why, Jalen. Very good, Jalen. The reason it is false is because your glassware may contain something at the bottom of the glass that was left over from a lab where the student didn't exactly clean it out well. You don't know what it is. It could potentially react dangerously. We need to make sure that things are clean. Number 6, when cutting something, cuts should be made away from the body. That is true. You don't want to cut towards your body. You don't want to hurt yourself. Number 7, the room is equipped with a fire extinguisher and fire blanket. True. Number 8, the Bunsen burner should be firmly secured to the gas line. True. Minor accidents do not have to be reported to your instructor. That is the hardest false. In this class, I want to know every accident. Whether you stubbed your pinky toe on some unknown substance on the floor, or whether your hair catches on fire, I want to know everything. And lastly, question number 10, true or false, always follow the lab procedure given to you before lab time. That is absolutely true. On this laboratory manual, you're going to find detailed steps for every single thing that you need to do during your lab time. Please make sure you follow those steps, and we will have a fun and safe lab period. Please hand in your quizzes, and we are going to continue our lecture in chemistry beginning with atoms, molecules, elements, and the periodic table. I hope you enjoy it. Thank you for doing so well on your quiz.